So now we're coming to a different field. We are not talking about laparoscopy. We are talking about flexible ureteroscopy or retrograde intra-renal surgery. And you know very well, even if you are Olivier Traxé, you need basically maximally 3 hands or minimally 3 hands to control the scope at the meatus, to deflect and rotate the instrument, and then to insert a laser fiber. And you need then 3 feet to control the irrigation maybe by foot, or if you have a pump, to activate fluoroscopy and to activate the laser fiber. So this is working, you can do this as a team, but it's not very nice, and probably this was the idea primarily to use a robot for this. Dr. Desai used this Hansen system, which was designed for cardiology, and you see this is an X-ray, and this is a kind of joystick where you can manipulate a catheter, and instead of a catheter, of course, you can also manipulate any flexible instrument. So what he did, he replaced the catheter. As you see here, the catheter in the heart, and then they replaced it with a flexible ureteroscope, and they did some clinical trials and published this in 2010. Unfortunately, or whatever you can say, this cooperation has been stopped. There was a problem with the size of this flexible ureteroscope. More or less parallel, I heard in Ankara 2011 first time about this system from Turkey, and here you see Dr. Remzi, not only here on the podium, but also sitting here behind this prototype, and he showed me this device at a meeting in Ankara consisting of a console and a manipulator. And this was a prototype indeed, and we tried this shortly after with a URS model. You know this from Cook, for example, in vitro model. And what was really, they asked me about my opinion about this, and I could say the deflection and rotation has to be finer. It was a little bit rude for minor movements, and we need a better design of the console. You see a very small screen, and at that time there was an endoscopic monitor directly integrated in the system. I said maybe this is not necessary because you do not depend on this, you have to have it versatile, and so this was the way to go to the next step. And finally, this is the Avicenna robot that I have used this year. The manipulator is applicable for all rhinoscopes. You see me here just putting this on. This takes just about a minute to dock the robot. It has significantly improved maneuverability of the device. You have a 30 degrees rotation, and of course a new design of the console. And this is now the scenario of this case, and I must tell you this was, I used this basically the first time, and after 4 minutes I was seeing the stone. So it's really, I tell you, I worked with the Da Vinci 2000, and at that time the first prostatectomy took me 10 hours at that time, so with nothing available. Here I was at 4 minutes at the stone, so this is a completely different situation dealing with new products, because this is really designed from urologists for urologists, and you see here this control panel. What has been improved? Initially there was a kind of mini wheel here for fine-tuning. This turned out not to be ideal. This has been exchanged in a bigger wheel that works very nicely. The handpiece is really ergonomic for flexion like you are used to use it in your hand. And then you have a fine-tuning of the flexion of the left side via the central wheel, and of course you have also, as I just see it here, this is advancement, and you can also fine-tune the advancement. You can regulate this, like you know this from the Da Vinci device, and this is this wheel in the central part. And here you see you can really, the speed that you introduce your instrument or you go down. Moreover, the degree of rotation is displayed and the degree of deflection is displayed. And so you always know where you are. Of course, you can do fluoroscopy. Additionally, you can see this, but you are really in the way to control this. As once you see, then the very important thing is also the console has an adaptable armrest. You can put it for your side, similar like the Da Vinci device. And more important also, the deflection is adapted either to an US or to an European system, you know, that works differently. So you can directly click on US and then you have this way. So I think they really thought about this. Then you have option of irrigation and the laser, and I come to this issue a little later. So here you see the ergonomic joystick for rotation and the fine-tuning again. Now the laser, you have to put in the laser here with any of these devices to stop the irrigation. And once the laser is inserted, then with this panel it's insert millimeter-wise and you can retract it. So you can really monitor this during the case, and I think this is very important. The irrigation pump, in this case we use from outside. If you want, you can do this. Also you can put this, of course, to a pump. The nice thing is you are working with your feet, activate the laser, you are working with your hand, and you have still time to take a coffee. You can do this, you know, with the Da Vinci, but then you cannot work, because the Da Vinci, you have to be at the console. With this device you can have a cup of coffee and you can continue. And as we learned from Olivier, you have to move to dust the stone, so you have always to move around, and I think this is, we used here the Auriga XL laser, and it works very well. Of course, here you see once again the rotation, and another thing which is very important in my view, you know, when Olivier explains us now using the digital scopes, where is the air bubble, that you know up and right and where you are. No need here, because you don't care which position it is like. With a robot, you don't care which position this has. You just look on your screen up and down is up and down. And this is another, I think, very important thing, an advantage of this system. So here you see the popcorning that we do. Sometimes you can, of course, use respiration to do so, and it works very well. Now, clinical experience, most of the cases have been done by Dr. Ramsey. 36 cases, mean docking time, as I said, 59 seconds, mean stone volume, about 1500 cc, square millimeter, cube millimeter, mean stone fragmentation rate, 32 cubic millimeters per minute, and all of the stones could be disintegrated. So in summary, the Avicenna robot has been, in my view, a very well-designed instrument. It's a free rotatable manipulator with fine movement, steerable at the console, adjustable to US and European endoscopes, versatile for endoscopes and lasers. And the Avicenna Roboflex improves ergonomy significantly, sitting at the console with armrest, free control of all function. And in my view, it's really the future of flexible ureterorenoscopy. Thank you very much.